stage. So this previous stage carry will be coming from this operation. Okay, this P and G is something related to the operation of the in place bits. So this in place bits along with your previous stage carry that is getting propagated should be the final result. No? What is a normal procedure of addition? In place bits getting added with the carry coming from the previous stages. So actually this stage is what you say, the operation of generating the carry that is being propagated to the next stages, this stage. So ultimately what we are doing is to this pre-processed propagate and generate, we are considering the carry that is being generated from the previous stage or until the previous stage. Until the previous stage. So this is P of I previous stage carry. Present P of I with previous stage carry. Present P of I with the previous carry. And the same thing for every stage. Here the present P of I with the previous stage carry. 1 XOR with 0 was 1. 0 XOR with 0 is 0. 0 XOR with 0 is 0. 1 XOR with 0 is 1. 0 XOR with 0 is 0. And the carry that will be taken is after your what you say, the prefixing of the values. When the carry gets settled, that value will be considered. So that is what is the value of G of I that is getting generated at that stage will be the carry at that stage. Is it fine? So three operations, we tried to split the steps into 3 operations. We are splitting that. Okay. Now, shall I proceed to the next topic? If it is understood. No answer.
Yes, ma'am.
Ma'am,
Yeah?
ma'am, the reason you stopped here is because both the rows are same, right?
Not same. Not same. See here, for this fellow, is there any neighbor? Like here, this is the neighbor of at distance 1. No? This is with the neighbor of distance 2. The next neighbor should be at distance 4. This doesn't have any neighbor distance 4. This doesn't have any neighbor at distance 4. This doesn't have, and this doesn't.
Okay, ma'am.
They will be stopping. If the neighbor ceases to be present, then we'll be stopping. Or a simple 5-bit if you take, we can see the iteration thing increases. Say something like, say, let us add 0, 1, 0, 1, getting added with 1, 1, 0, 0, 0, say. What is the result? 1, 1, 0, 1. This should be the result. So literally, what is the value? What is the value of this? 21 plus of 24. Correct? 21. This is 21. This is 24. So what should be your value? This should be 45. Is this 45? 1, 16, 32. So this is 45. This should be the result. So quickly, let us do this. So this is 1 over 1, 0, 1. The in place bits I am writing 1, 0, 0, 0, 1, 0. For this, what is PG? Propagate, generate, propagate, generate, propagate, generate, and propagate, generate values. Okay. Just quickly give it. What is the propagate and generate is 1, 0. propagate and generate is 0, 0. And for this, generate is 0, propagate is 1. And for this, generate is 0, propagate is 1. For this, generate is 1, propagate is 0. Okay, so this neighbor, distance of one neighbor. This distance of one neighbor, and this one doesn't have any neighbor, so this is settled. This is settled. So now what is the value here? 0 and 0 or 0 is 0. 0 and 1 is 0. Okay. 1 and 0 or 0, 0. 1 and 0 is 0. 1 and 0 or 0, 0. 1 and 1 is 1. 0 and 0 or 1 is 1. 0 and 1 is 0. The second stage equations. Now, this is the second step, a communication to the neighbor which is at a distance of 2. So there is a neighbor which is at distance of 2, but this fellow doesn't have a neighbor which is at distance of 2. Actually, this should be the distance. Neighbor placed at this distance, there is no neighbor existing, so this is settled 0, 0. And here also this is settled because there is no neighbor. Now, take these two. 0 and 0 or 0 is 0. 0 and 1 is 0. 1 and 0 or 0 is 0. 1 and 0 is 0. Next. 0 and 0 or 1 is 1. 0 and 0 is 0. So this is the, what you say, you can take this as a carry generate, carry kill, or carry propagate conditions that are existing. Now see, this fellow is not having a neighbor at 4, distance 4. This doesn't have, this doesn't have, and this doesn't have. Whereas this fellow has a neighbor which is at distance 4 now. This is at distance 4. 1, 2, 3, 4. Okay, and these fellows doesn't have the neighbors at the distance of 4, so these are settled. 0, 0, and this is 0, 0. Now, what is this value? 0 and 0 or 1 is 1. 0 and 1 is 0. Okay. Now we need to see Ci minus 1. That is, say if you take this is C1, this becomes C0. C0 is 0. S1, C1. S2, C2. Sorry. C2. S3, C3. S4, C4. S5, C5. Okay. Now what is S1? 1 XOR with 0 is 1. Generate is 0. Generate directly we can take 0. This is 0. This is 0. And this is 1. This one is 1. Some value is 0 XOR with 0 is 0. 1 XOR with 0 is 1. 1 XOR with 0 is 1. 0 XOR with 0 is 0. So this is your result. This is your result. That result is 1, 0, 1, 1, 0, 1. So this is same. So that is equal to 45. Yeah. So where you have to stop is when the neighbors are ceased, there are no further neighbors available for communicating, then we say that that stage of generating propagating carry is settled. Okay, so I'll go to the next topic. If it is understood, we'll shift to the next topic. Yeah.
Yes, ma'am.
Recording I didn't do. No one has mentioned. So we go for this PLDs. Little bit of PLDs information we try to take. What exactly is this element of PLD? PLD is the programmable logic device. Okay. Actually, what is the need of this is, say we had standard building blocks, and all these building blocks, when we integrate, we were able to get a needed specification or a needed design updated or integrated, we were saying. Okay, so we can implement this within the chip if there are some provisions of generating the min terms and max terms. Okay, what were this min terms and max terms? That was and terms and or terms. Okay, so something like when we were defining the, or when we were designing the circuits, we were taking the help of the lower level of logics or lower level of designs that we were integrating or something like grouping them together. We were able to generate or develop a higher level complex designs. Okay, so in this, the logic devices what are available for our use are something like memories, different types of memories. We had something like ROMs were there, RAMs were there. Okay, and the elements of programmable array logic, programmable logic arrays are there. Okay, these are the devices we say PLAs and PAL devices. Okay, and all of these devices we can categorize them into something called as a complex to programmable logics, something like complex programmable logic devices, we can say CPLDs, complex programmable logic devices, or we can categorize them as FPGA, field programmable gate arrays. And in this, they'll be having or they will be accommodated with the flip-flops, some gates will be there, or some complex functions if you want to implement. The lower level of building blocks will be available for generating the higher level circuits. Okay, so in these always designers used to like these PLDs, which are more prominently used are PALs and FPGAs. Most prominently used are PALs and FPGAs because they give some easiness in the design. Any design with less effort, they can develop the higher complex designs. Okay, so the reasonable integration ability is available, allowing the implementation of significant amount of functionality on one physical chip. So this will be facilitating us to have on-chip designs. On-chip designs. That means without removing the circuit as it is from the base, you will be able to design. Okay, so these designs like these PLDs, you can use them as off-the-shelf devices, or we can interconnect the devices within the chip itself without having or without in need of extra wiring. External wiring is not needed because there will be the tracks which is connecting the components internally. Okay, so that is the what you say, very convenient way of designing a digital circuit. And many programmable devices allow reprogramming also. Okay, it is easier to change the design in case if there is any error happening or any change in specifications. When some designer in between they want to define more number of parameters into, they want to incorporate many parameters, that means they can change the specifications, or else something like if in the process of design there is an error happening, the designer has the flexibility of what you say, reprogramming the logic or in such a way that the error can be erased or more added complexity can be added. These two ways the PLDs will be facilitating. Okay. Now these PLDs will be coming in different types. Something like the devices that can be programmed only once programmable sort of devices, or reprogram for many number of times. Okay, so these we can categorize them as the one which is programmed by the user, we call it as field programmable devices. Okay, and the one which is which is at the factory end will be programmed. Okay, they fall into the category of what we say what is a factory end defined logics. Factory end defined logics. Okay, or what you say, factory programmable logic. Factory programmable logic. Field programmable logic, factory programmable logic. Two ways to define. So these fellows will be defined by the factory. That means the user doesn't have the flexibility to reprogram this. Whereas FPGAs, this is at the user end, you can program this programming also. You can few devices they allow multiple number of times reprogramming. Few devices they allow only once. Few devices they allow with some erasing procedures. So this is something to the user end. When a designer is taking up a new design, this type of PLDs will be preferred when compared with the what is a factory programmable logic. This a known logic is there in our design, which is already defined by the factory. If it is there, maybe conveniently we can take factory defined element. But we don't know what is the logic, or we don't know what is the combination of the connectivities and the component interconnects and all. Maybe FPGAs are better suitable things. Okay. Often the designer prefers FPGAs in place of factory programmable logics. That is the what you say, the basic conclusion we can give. So this programmable logics, if we can classify, so I divide this into factory programmable devices and field programmable devices. Under this, most prominently you'll be knowing, or without basic knowledge, we must have read all these categories. Okay. Something like the ROMs come under factory programmable. They'll be programmed by the factory, read-only memory sort of thing. And you can say mask programmable gate arrays, mask programmable gate arrays, MPGAs. These two are the category of factory program. And if I categorize the field programmable, what we have is simple programmable logic device, simple programmable logic device, complex programmable logic device, and field programmable gate array. Okay, so in this simple programmable thing, we can accommodate the prompts or programmable logic arrays or the programmable array logics or the generic array logic, GALs. Okay, so in this also we have EEPROMs, where reprogramming method makes it as EEPROMs or EEPROMs, electronically erasable prompts or electronically erasable prompts. That means one-time reprogramming or double or multiple times reprogramming. The technique of reprogramming categorizes that into EEPROMs or double EEPROMs. Okay, what is the difference between this PLA and PAL is the general structure of our designs will be of SOP or POS format. Means that it is the combination of and OR logics only. If you can put this into a proper format of true complement element and define the min terms and max terms, you are able to define the total design. Okay, so min term is an AND operator, max term is using an OR operator. We can implement physical design if you take. So here maybe if we take the difference between the programmable logic array and programmable array logic, here both your AND and OR logics are programmable. Programmable in the sense you need to define the connectivity of the AND operated inputs and OR operated inputs. Whereas here for PAL indicates that it is a little bit user friendly and which is having what you say less effort in defining the terms. In the sense you will be having a programmable and fixed OR. Programmable and fixed OR. The terms of, say, if you are taking SOP, this AND operator you need to define and the OR operator is already fixed. That means there is no need for you to program this, only the AND logic only you need to program. Okay, but what is the not disadvantage we say? If more bigger size of AND operator is there, bigger size in the sense more number of inputs are there for the AND operator, many number of inputs are there. If there is a limitation of number of inputs to each AND gate, maybe you need to take one or two different paths and you need to define them. And because this is fixed, you need to redefine or the connectivities has to be defined. You need to club bigger size of AND gates for the fixed OR gates. So that is one element of what you say, the programming that needs to be added. Okay. So in this, ROMs can be considered as earlier form of what you say, the programmable logic. Earlier forms were ROMs, and this MPGAs are nothing but gate arrays. These are gate arrays. These were gate arrays, and this was used for ASIC applications. Okay, creating an application-specific integrated circuit, a circuit of that level. If you need, MPGAs were used earlier. Okay, the in almost in the early 70s, 1970s itself, the and/or logics were developed for the beginner level of digital designs. Okay, and that were called as FPLAs in place of FPGAs earlier. This is field programmable logic arrays. Earlier they used to call them as logic arrays having the and/or logic only. Simple. Okay, something like the monolithic memories company and AMD companies, they used to take only these type of array elements, gate arrays, and they used to develop the designs. But later, when it like got developed, the number of pins added to the packages increased, and almost 20 to 24 pin packages were developed at the beginning in 70s. Okay, nowadays what we get is in thousands of pins. A very drastic increase is there. Okay, so for this PLAs, your what is the programming what should be programmed is we need a programmable AND array and a programmable OR array. Both these, the arrays to be programmed are both AND arrays and OR arrays. Whereas that means user needs to implement the combination function of the two levels. Okay, but when you take the PALs, in that your OR array is fixed. This array of OR is fixed. Only this AND array needs to be programmed. Okay, so even in this parts, not only like programmable and logic fixed, or they will be having flip flops also added to the circuit. Okay, why we need this place for generating the QQ bars. For AND logic, something like generating your input combination directly, say if X, Y, Z is there, in your design, we need X dash, Y dash, Z dash also. So altogether, we need X, Y, Z, X dash, Y dash, Z dash. For these becomes the inputs. And QQ bars, if the sequential parameter is there and you need to find the status value also incorporated into your design. which will be taking the inputs, how many number of inputs you define, that many number of inputs in its true complement form it will be available. So n number of inputs, and this PLA logic combination of ANDs, how many are possible, will be given to OR array, and this gives you m number of output lines. So this is your basic structure of PLA. This is basic structure of PLA. Now how to implement this is something like this. If we take, these are word lines, you can say these are word lines. This is a combination of these inputs. This means, that means your minterms will be, the format of minterms will be available here. Maybe this you can take it as max terms, or the OR operated minterms. Okay, say if I want to implement an equation of, say, that means we are mentioning that we have four inputs W, X, Y, Z, and we need to have W in its true or complement form, X in its true or complement form, Y is in its true or complement form, and Z in its true or complement form. Okay. Now, based on your requirement, wherever we need the type, so W dash X, this gives you one AND gate. Okay, and X dash Y, X dash, and this is it. So this will be your OR logic. Something like this. Okay. OR logic, we will be tapping this. Something like one equation directly we take here this tapping. This is your OR logic. This is equation 1. So this AND array, OR array. This is your AND array. This is your OR array. The format will be like that. Okay. This is a known element. Now, what is that we are programming? We are programming both and we are programming OR also. But for program array logic, if you take, okay, each input will be available in its true or complement form. Each input will be available in what you say, this is non-inverted form, and this is inverted. So wherever we want, that will be tapped. And this OR logic will be fixed, and this AND logic we need to program. Okay, based on what is the equation we are implementing for, we will be programming this. So something like I have say an element of x1 and x2 dash to be implemented, say x1, x2 dash, or x1 dash, x2 sort of things. Means that I need to have x1 which is in its true or complement form, and x2 it will be in its true or complement form, and here these fellows will be like one logic, this is another, this is third, and this is fourth. Okay. These are the connectivities. Now, for this, every what you say, if it is not programmed, here you will be having the 4 inputs available to your AND. more inputs available to your and which logic you want to implement, only that will be intact and the others will be fused out. Okay, what you want to implement, that will be fused, the others will be blown out. The others we can blown out. So maybe if I want to erase something like I want to have x1 x2 dash, x1 x2 dash. So this is x1. I put a cross there wherever is the fuse is intact. So this is x1 and this is x2 dash. This will be intact. This will be blown out. This will be blown out. Next, x2, x2 and x1 dash. So this will be connected to a fixed OR gate. OR gate is fixed. This is not needed to program. This is your output. Now this will be x1, x2 dash or x1 dash x2. So this is previous one without this blowing thing. This is unprogrammed. If you program them, that means fuses being blown out, which is not used, and the fuses will be intact, which are in use. That is the programming portion. What you do only for AND gate, and OR gate is already fixed. It is present there as a predefined connected logic. Okay, so a sequential pile, as we said, will be having a flip-flop also, along with this true complement form of your what you say, the inputs. There will be an element of, like if it is a sequential pile, we can have this flip-flop which is generating us, or which is providing us an element of, what you say, you can put this into either, you can take this or this to an, this is your true form, this is your complement form of q bar, again available, like here we had x1 x1 dash x2 x2 dash, no, this q bar will be available for this AND logic. Okay, for this AND logic, you can have this. If the equation is, say, a sequential circuit design equation is to be implemented. Along with this becomes the status, no? This is your status. Without that, this is only combi. Okay, this is only combi. So the programmable AND will be provided with q bar also through a flip-flop setup in order to implement a sequential design. For a combi direct, only this setup is made. Okay, so maybe I'll stop here. No further doubts are there, I'll stop. Yeah, no doubts, I'm closing the session.